I'm a retired geologist with the Tennessee Division of Geology, and one of my interests was this feature, which is called the Wells Creek crypto-explosive feature, or many other names also. But something happened here a long time ago, obviously. It was discovered back in the 1850s by the railroad engineers coming through. They had no idea what it was, but they knew it was not normal or out of the usual. But this is a structure map. This is a surface geology map. The colors just indicate ages of rock. All of the different colors should be flat. Everything should be one color all the way across. If all the strata were flat lying, which it normally is. But all these colors indicate these rocks are pushed up. Something caused these to be pushed up. An early theory was volcanism, which, okay, that sounds pretty cool. It's totally disprovable, but it was a pretty good idea. There are people who still believe that, but you know, we always have our wackos. But this has been extensively mapped over the years, starting back in the railroad found it, discovered it, I think, in the early 1850s, if I'm correct. And then the first state geologist rode across on horseback in probably several years later, we don't know exactly. But it was mapped in the 1860s, I think, something like that. Anyway, and from then on, it's been looked at quite a few times. In the mid-60s, Vanderbilt and the Tennessee Division of Geology came and wore it out, really wore it out, and did all kinds of research. And this is one of the many things that was produced. And there's a publication that this comes from, which the Society has several copies of, and I can get you a couple more copies. I'm sure most of you would like to look in it, check it out. It's very interesting. It gets a little technical even for me, so I leave certain parts of it alone. Anyway, it's a fascinating story. But anyway, getting back to this right here, we started our little trek back down at the south end of it at a spot called Dolomite. You might know why it's called Dolomite. I don't know. All of native rock around here is limestone, except for the stuff in the middle, which is dolomite. Maybe that's the reason. But I don't think there's any dolomite down there. That's the thing that's funny. Anyway, where we are right now is, if I've got this turned correctly, okay, you're right up in this area. The steam plant is at the north side of this map. Here's the Cumberland River. These lines that you see coming out, these are all mapped faults. Some are inferred because the researchers couldn't put their hands exactly on them, but there's enough evidence in the form of breccia and other exposures to determine where the faults were. And some of them are plain as day. They're the good ones. But they're all over the place. You don't see any faults in the middle because when the structure, the meteorite, struck, as you can imagine, it obliterated what was there. It turned it into a messed up, no more layering limestone, you know, no more fossils, none of that. It actually pushed this mass of dolomite, which originally was laid 2,500 to 3,000 feet below its original position. It pushed that up. The meteorite struck, went down, caused compression, and then blew the stuff back up. And Central Hill, which we're going to see in a little while, is this right here. And it's just, it looks like a hill, but it's a very different hill because it's much, much older. It's much more resilient, it's harder rock, and it's got shatter cones and all kinds of strange formations in it, which you don't see as a result of normal sedimentation. But it's very strange, needless to say. But getting back to up here, this location you see, here are two faults right here. That, okay, let me go back a year or two. Back in the early 70s, I know several Vanderbilt students who came down here with Richard Stearns, who was one of the authors of this publication, and they just did field trips. They just stomped across the land looking at what they could see. There was no steam plant here. There were no exposures to speak of. There were no great road cuts. There weren't any cuts like this. But I remember them saying that you could see in this general area where the steam plant is now, there were exposures, rocks sticking up, things that were very unsedimentary, very unnatural for this part of the country. And of course we knew that all this stuff was here, but it wasn't exposed in the way it is now. But I remember them saying that they saw it was very, very different. It was almost like over in the Ducktown region where they have the term Basin bedding, where bedding comes up to the surface through folds and bends, and you see stuff outcropping in straight lines, minerals, just discoloration because of the mineral content of the rock. That's what it sounded like to me when it was described to me by the Vanderbilt guys, and I wish I'd seen that. There's Miss Finley.
Oh, right here.
That study of that you got from the TVA engineer or whoever it was, the stuff that's at the library now.
The pictures.
The pictures. That's magnificent because that shows what my Vanderbilt friends saw on the top. And then when the engineers came in and started excavating the rock, the dirt away, the pictures that are at the library show the very unusual rock formations that they encountered. And I'm sure it was a pain to build this place. It had to be a lot of dynamite. I don't know. But anyway, getting back to this. What we're going to see right here is an incredible exposure, and I can't tell you exactly where it is because I don't know exactly where we are on the map. I know roughly, but I can tell you that it's associated with these two falls, and that's a bucket of guts to say that. I mean, it's a mouthful, but you can see, and I can try to explain what took place. Yes, sir.
What happened to the material
that hit here?
Blew up in here.
Okay, a lot of it as ejecti or whatever got turned into dust and blew away. Most of it stayed right here.
So it just came right back.
Came back down. Yeah. And if it had been a volcanic type of thing, there should be evidence of volcanic rock around here. There's none at all. There's nothing that even resembles an igneous type rock.
Maybe iron modules? Or?
Yeah, there could have been that if the structure from outer space, the meteorite or whatever, had been like nickel, iron, which most of them are, there. And it depends on how it strikes. Some come down and explode right at the surface. Some actually penetrate the surface and explode in the subsurface. We don't know every time. But the type that blow up in the atmosphere, they leave the iron evidence laying in fields around.
I do have iron modules on my farm.
They're around here. Now the iron is very common around here, but it's a result. It's a natural result of sedimentation. It was already here.
Is it true that NASA did some drill samples over here?
Yeah, I'm not really. Somebody drilled the Central Hill, and I used to think it was NASA. It was a private contracting company, and
University of Massachusetts also came back.
Yeah, there have been other people come, but NASA, I think, deepened that 2,000-foot hole 500 feet more. And I'm not really positive about that, but that's what I've read. I think it's mentioned briefly in Bulletin 58, which is this thing here. But and they cored this area here for the foundation of the plant. They had to see what's in the subsurface so it would support all this weight, obviously, you know. And so they cored this. I don't know what TVA did with that core. I'm sure it's been looked at many times. It's maybe been trashed by now. I have no idea. But that would be interesting to see. But the most interesting core is of Central Hill. That's the big 2,500-foot hole over there. I've seen some of it, and there are pictures of it in the book. It shows brecciation, which is one of the features that's caused by this phenomenon. Brecciation also happens naturally in sedimentation, and I'm going to show you some breccia, which is on the property here, but we can drive to it over back over here. No hard heads required. And their breccia has come out of the pit where it's flooded now. I've got a hunk of that I can show you. And breccia has also been found in Central Hill. And there are different types of breccia, and that's all I can tell you about that.
Where's Central Hill on the map?
The Central Hill is right here.
Okay.
We're not going to be able to go over there. It's too muddy.
Right, that's what I thought.
can't
And this is too big a crowd, and we don't have time.
I can go in with four-wheel drive.
Yeah, I figured it might be a little muddy.
Common River's high, and that's what's got
Oh,
it back
goodness,
there.
yeah. Well, this is mapped as being underwater. High water. All this is water. You know, I rarely see, you all probably see it up in here like you were talking about. But what I was going to do, and I don't know if we can do it, but I was going to park at the Scott House, and look at it from there. It's just as impressive to see it from afar as it is to go to it. If you go to it, we can do it in the future. I can arrange a trip where we can go to the hill with picks and hammers and actually look for shatter cones. And that's fun.
Anybody, we'll be going on a gravel road to the Scott House, and if anybody doesn't want to have the mud on their car, don't go. We're going to be on a gravel road before we go through the cow pasture.
There's also an old road that comes back on the other side.
Yeah, we're going to go in from the north side to the
Scott
south, but we're going to go down the road you're talking about. So there's, a little mud
You
never hurt
can
it.
go up and cross over and come down the other way.
Yeah, I don't know. I'm not even sure because I had it all planned the other way. But I'm with the pro. Yeah, Jerry.
Right
Jerry. Too many camcorders here. Anyway, does this make any sense at all? These colors. If this right here, let's say we go west of here. No, let's see. Yeah, it doesn't matter. Let's go north, okay? If you look at the geologic map of the quad north of here, it wouldn't have as many. It would have maybe one or two colors, and they'd be bigger blobs because they're flat-lying rock. And this is most unusual.
How wide is the center crater?
Pardon me?
How wide is the center?
A couple thousand feet. The entire structure, they say, is like 8 miles across. That's a little exaggeration, I think. That depends on what you call the structure. It's 6 to 8 miles.
The center structure is...
Now you're talking about from hill
I'm
to
talking
hill.
about from ridge to ridge because actually the outer Cumberland City Fault, which is the outer annular ring of the total structure, is up on that ridge. Now, when you go back towards Clarksville and the ridge behind Rise and Shine, the faults are actually behind him, and they actually go up between the lake over here and Cumberland City.
So there's several ridges that are pushed out from this impact crater.
Right, but the bad thing about the ridges is that this stuff was deposited on after the impact. It was eroded down and then dumped on again. That causes a little problem. But there's still enough evidence. There's tons of evidence, like Central Hill. And all these faults. These are not fabrications. These people put their hands on either breccia or crack in the rock or good evidence somehow. If there's none of the above, you can't put a line on the map. There has to be evidence. And we need to, I guess.
I know we don't have enough of these,
No,
but
no.
could we just have people share?
Yeah, we're gonna have to.
Okay, but I mean, I thought maybe now was the time.
I'm not prepared at all.
I thought now was the
I
time.
made a little handout here, and
And this physical list for the minutes.
well, yeah. I only made 10 or 11. It's terrible. But there's somebody behind the viewfinder of the camcorder that caused all this, and I'm very happy for that person. But I'm in shock because I was counting on like 10 people.
So where is this hill? Is this the impact?
This is roughly the impact, yes.
Is that in Stewart County or Houston?
It's the line. The line is below. The line is right here. So most of the structure is in Stewart, but the structure does get a good bit into
Houston.
Houston. I'm from Montgomery. That's what I'm totally lost.
Was it a
I've only
direct
been down
impact
here.
or does it come across? Okay, so they
You mean it come like this?
Yeah,
like
they
that?
ain't gonna
No,
put
it came out of the northeast, they say, because that's the way the shadow cones are positioned in the quarry. But at an angle kind of like this, pretty steep. I don't know exactly. But what have I missed? A whole lot, I'm sure. At this location right here, there are only 10 of these, 9 of these, so you got to pass them around and you can copy them and all that. The cover is from a publication that was published by 4 geologists that I know and have worked with.
From the University of Tennessee?
Of Tennessee Tech. And the cover is a great illustration because of the color of the Horst and Graben units. Horst and Graben is just where one hunk of rock has gone down, the other side has gone up. That's it. That's it in a nutshell. But
Is there something you want to talk about specifically in here?
yeah.
No? Okay, sorry.
Yeah, there is. I'm sure. This is just different colors. This right here is just the center. This is the central megabreccia body of the structure itself. This right here. This right here goes way past the river because some of these ring faults go out. To the north, there are faults across the river up here that have displacement of like 300 feet in the units. You can't see them, especially now. Everything's covered up now. Everything's overgrown, developed, plowed over, whatever. So many exposures are not here. This one right here was not here. TVA made it available. Thank
This
goodness.
happened 100 million years ago or 200 million?
This is one of the most difficult structures to date on the planet, and they say because it's difficult, because it was so long ago, and then it was covered up with other age rocks. They say it's give or take 200 million years. What's that for an age? Give or take. Okay. I mean, a million years to most normal people. I'm not normal, but a million years is a long time. We're talking. This thing might be, the age might be 200 million years off of what you think it is. We don't know.
We dig like 2 or 3 feet down on the farm. We find coral.
You found coal.
Coral.
Coral. Okay. That's okay. That has nothing to do with this. That was already here.
Yeah.
That actually came. That was deposited. That's Mississippian in age, more likely, and that's what all this stuff on the outside is Mississippian age rock. Fort Payne, St. Louis, Warsaw, and fossils are in that stuff. A lot of fossils, corals, a lot of great fossils. Fossils that were here were totally obliterated. You get farther out a little bit, and you get fossil hash. You get fossil fragments you can see in a microscope that were, smushed up. They weren't turned to dust, but they were busted up pretty bad and then put back into hard rock, re-solidified, whatever. But in the middle, it's a mess. It's a beautiful mess. Very, very interesting. Getting back to the handout, this is a larger picture of the same thing, and thank you. And description on the inside. This little map right here shows some of the places we're going to stop, the ones that are highlighted in yellow. All of the little faults have a name. Geologists, just like road makers and county people, name everything. Rocks, sediments, mountains, everything's got a name. Yeah, that's cool. And so we're in the close proximity to the Steel Ridge Fault and the Indian Hill Fault. means nothing to me, but some of you have heard those terms. There's a Maryville Hollow Fault, there's a Cumberland City Fault, Erin Fault, all kinds of, they're just named for areas that they pass through or whatever. But this is interesting to see the names.
And then University of Cambridge came here?
I bet they did. There's no telling how many people did here. I just know about Vanderbilt and us, but I guarantee UT.
You're just our expert. I
know very little about this
I don't
thing.
expect you to know everything.
No, actually, I know very little. Every time I pick up Bulletin 58 and go through it looking for something I'm interested in, I find other things that I didn't see before, or things that I
Well, I think University of
misinterpreted.
Cambridge.
But anyway, it's a fascinating book, but it's very technical. There are some chapters that even I understand, thank goodness. This is another simplified version of the structure map, and when you're able to get a grip on this thing right here, you will be impressed by the age of the rocks and where they are on this map right here. Like I said before, the center bit, the very center, is Knox Dolomite. It's the oldest, it's the deepest rock around here. It was pushed up almost 3,000 feet. It originally lays, if you go out several miles and drill down, the Knox is 3,000 feet. This sucker was pushed all the way up and mixed up and pushed up. It was pushed up in little bitty pieces, mega blocks. There's a block in the quarry that's flooded right now. That's in the very edge of this structure, and there's a block in there that the geologists started to interpret. The beds are vertical, and they started reading the rocks from left to right because these are overturned beds, and the rocks used to be like this, and they were overturned like 110 degrees. And I think I read somewhere, and maybe in Bulletin 58 or another publication, that most of that quarry is one big mega block that was pushed up and turned over, and it's 500 feet long. And that shows you the scale of this operation, of this hit, this whatever it was. But that is one piece of rock. And when you look at that, I've got pictures of it when it was dry, and Jerry's been there, and other people have been in that quarry maybe when it was dry, and I don't know if you noticed vertical bedding in it, because normal people don't look at things like that. We always look for the weird things, but normal people just look at good stuff. And first thing we saw when we walked down into the quarry was all these beds that were standing straight up. I was like, wow, this is good. This is not right. This is really good. And that's what they were. They were overturned to the tune of 110 degrees. And then I read later that block was almost 500 feet long, which is just unbelievable. How much power does it take to move blocks of rock that large? Only the computer can figure that. But anyway, we need to start moving. The last thing on this, here's a picture I'll show you later. The last thing right here, talking about the big picture of this feature. This is a different scale map. Nashville. The Nashville Basin is an erosional basin. If you ever notice when you drive into Nashville, you drive down from almost any direction, except if you come up from the south and you come into it a little bit more gradually from the south. But when you come from the north, east, or west, you go downhill to get into Nashville. Some areas it's very noticeable, and so that's there because there's a feature called the Cincinnati Arch, much larger feature in the subsurface of this part of the country, not this part of the state, this part of the country. The Cincinnati Arch caused a bulge that, I forget which way it goes. Anyway, it pushed up the land in central Tennessee. It actually pushed it up. You can see that, you can read the rocks all the way around, and they all dip away from downtown. They do. There are a few little spots that they don't, but most of them do. And we put all that together, it's pretty obvious what took place. But what happened was the rocks were pushed up gazillions of years ago. They were already solid limestones and shales, and they got fractured in the pushing motion, and after eons of rain, they got eroded away. And so now you have all this crackle stuff in the middle that got washed away, leaving a basin, which is a bizarre concept, but it's proven, and I like it. I think most people agree with it. The bottom line here is this is Ordovician age rock. This is a little bit younger than the Knox out here, but you see the pink. Over here you see a kind of a pinkish yellow in the middle. This stuff right here is even below this. It's even older than this. And so this right here, just all this up here, all this other blue rock is Mississippian age rock, which is out from in every direction. Just plain old limestone for miles and miles and miles. It's all roughly the same age. But these little spots here show you age difference. And the anomaly here is the fact that it's circular. That's not the way the rock cycle works. That's not the way mountains are formed, you know. But this right here obviously is something that took place like a meteorite, which we're sure it is. But take a look at this picture, you know, when you get a chance. And to me, it's very impressive. But